As our lakes and oceans struggle with pollution and overfishing, aquaculture continues to play an ever-increasing role in providing fresh, high-quality seafood to consumers. From the giant catfish of Vietnam to the crawfish of the Louisiana Bayou, aquaculturists and fish farmers across the world are successfully raising a variety of fish and seafood for consumption. Aquaculture endeavors can range from backyard tanks to large commercial operations for both local consumption and exports. One of the most popular species of fish for both consumers and fish farmers is tilapia. Global production of tilapia has increased from less than 200,000 metric tons in 1984 to over 2.5 million metric tons in 2007. Over two-thirds of this volume was produced in Asia, with China, Bangladesh, Indonesia, the Philippines, and Thailand being the top producers. By 2010, world tilapia production is expected to be 3.5 to 4 million metric tons, representing a value of almost $5 billion. Tilapia has also gained favor with American consumers. In the year 2000, tilapia was tied for 10th place among seafood eaten by Americans. By 2007, it had risen to 5th place, representing an annual consumption of 437,000 metric tons. This represents an import value of almost $560 million. What makes tilapia a popular choice? Essentially, it's a fast-growing, tolerant species which represents high-quality meat to consumers at a very affordable price. Tilapia originated in the Nile Valley of Egypt and were one of the first species to be cultured over 3,000 years ago. Since then, they have been transplanted to many countries outside their native area and are now farmed worldwide. Tilapia are extremely hardy and disease-resistant. Such tolerance makes them well-suited for fish farming. They are omnivores and readily feed themselves in naturally fertilized ponds. Tilapia grow quickly in captivity, with the average grow-out time from fingerling to a marketable size of within 5 to 6 months. The Pacific Island region is the world's smallest producer of farmed fish, and although still in its infancy, tilapia farming is steadily increasing. Some of the challenges facing tilapia farmers in the Pacific are the high cost of fish feed, uncontrolled reproduction, which leads to stunting and other problems, and the lack of quality fry for farmers. In this presentation, we'll take a look at what's involved with operating a typical tilapia hatchery and raising healthy fry. First, we'll take a look at the basic systems for tilapia farming. Ponds are the predominant means of raising tilapia throughout most of the world. Most ponds are designed to be drained completely and thus dried out between production cycles. This is done to eliminate the carryover of fry from one production cycle to the next. Cages are another suitable method for use in large rivers or other bodies of water. They prevent reproduction by allowing eggs to fall through the mesh. Cages can be constructed in different shapes and materials. One popular cage method is the use of hopper nets. Tanks are good alternatives for when you can't build ponds or use cages. Tanks can be created from many different materials at many different costs. Tanks are often used for intense reproduction or hatchery operations. High-density tanks can also prevent reproduction problems with tilapia. There are many species of tilapia, but only a few are widely considered for cultivation. Choosing a species to raise is largely dependent on customer preference, growth rate, and cold tolerance. Major species of cultivated tilapia include the Nile tilapia, or Oreochromis niloticus. This is perhaps the most commonly raised species as it has the fastest growth rate. Another choice is the blue tilapia, or Oreochromis aureus. which is the second fastest growing species and one that has a greater tolerance for colder climates. The Mozambique tilapia, or Oreochromis mozambicus, is a species that is more tolerant to salt water. A fourth species, the Zanzibar tilapia, or Oreochromis ornorum, is also easily cultivated and adapts to both fresh and saltwater environments. Hybrids of these species are very common, and most available commercial strains of tilapia, even if they are called pure, are probably not from a single species. Tilapia strains have been developed in many colors over the years. The most common colors range from a black or dark green to a silver color, depending on the strain. Hybrid strains have yielded the popular red tilapia, as well as the white tilapia and gold tilapia. The consumer's choice for colors differs by region and ethnic background. Strains of tilapia that are primarily bred for color do not often grow quickly enough for commercial food production. For this reason, you should take a look at the growth rate for the particular species that you wish to raise. In tilapia production systems, the life cycle can be divided into the following key stages: broodstock, eggs, yolk sac fry, juveniles, and grow out or adults. In aquaculture, the broodstock is a group of sexually mature individuals of a cultured species that are kept separate for the purposes of breeding. Broodstocks are maintained for several reasons. First, they provide for eggs and fry in a controlled environment. Second, they represent a disease-free base from which to raise future generations. And they allow for selective breeding, which can help produce a breed that is resistant against diseases. Tilapia can reach sexual maturity very early. For example, the Mozambique and the Zanzibar tilapia can reach reproductive maturity at the age of 2 to 3 months and at a size of 30 grams. Nile and blue tilapia need 5 to 6 months to mature, but if stunted, they can reproduce at sizes as small as 1 ounce. This can pose a problem as a pond may have more stunted tilapia than harvestable ones. The males are territorial and generally build a nest in their natural habitats. The female enters the nest and lays her eggs. Once they have been fertilized, she picks them up with her mouth and begins to brood them. Tilapia are referred to as mouth brooders. The female can produce approximately 2 to 4 eggs per gram of body weight every 3 to 4 weeks. The smaller fish actually produce a larger number of eggs per gram than larger fish. Under tropical conditions, the eggs hatch in approximately 6 days. Unhatched eggs can be obtained by opening the mouths of all of the females and rinsing the eggs out once a week. If you do this less than once a week, you may find that some females have eggs that have already hatched. The newborn tilapia are called yolk sac fry, and they do not feed until the yolk is used up. Yolk sac fry continue to be mouth brooded by the female in nature. Even after they start to feed, they may take shelter in their mother's mouth. Hatching jars can also be used to hatch the eggs and mimic the mother's mouth brooding. The newly hatched fry have a yolk sac. Once the fry hatch, they wash out of the hatching jars and are collected in trays. In many hatcheries, yolk sac fry are assembled into single age groups before first feeding. This provides greater control and efficiency in the hatchery. Once the egg sac is absorbed and feeding has begun, the fry can double their weight in the first 3 days. At first feeding, fry should be fed 20% of their body weight per day of a high-quality 40% protein powdered feed. The feed should be given in 5 to 6 feedings spread throughout the daylight hours. Tilapia do not feed at night, so there's no need to feed them. Continually feeding can also produce uneven growth rates and cause cannibalism. Once the tilapia have reached an age of 30 days or so, they are referred to as juveniles. Juveniles are often stocked at much higher densities than the final grow-out stage to use the available space more efficiently. Feeding rates are decreased on a per-weight basis as the fish continue to grow. The grow-out stage usually refers to tilapia in the final stocking. It is during this stage that the young fish are kept until they have grown to a marketable size. Once the fish are stocked, they are not sorted or moved until harvest. Density of grow-out stocking is dependent upon the density desired at harvest. This is the controlling factor for your stocking rate. How many pounds per square meter or per acre you want at harvest determines the number of grow-out stock needed for a particular operation. The goal of a hatchery is to produce sufficient numbers of high-quality, healthy fry in the life stage needed by its customers, and to achieve this in the most economically efficient way possible. Hatchery customers may need smaller or larger fry of either mixed-sex or all-male populations. Therefore, it is important to investigate the needs of your customers before designing a hatchery. For the general hatchery operation, smaller fry and mixed-sex populations are the lower-cost options. This represents the best choice for many Pacific Islands. Extension outreach should then focus on production methods using mixed-sex fry. A hatchery operation begins with its collection of broodstock. The genetics of the strains maintained determines the quality of the fry produced. Therefore, care must be taken to preserve the purity of the strains as well as to prevent inbreeding. Within hatchery operations, it is good practice to avoid mixing strains within tanks, such as dropping fish or fish jumping between tanks that are too close together. Inbreeding can be avoided by keeping large populations of broodstock or by managing the pedigrees of the broodstock. This is best accomplished by keeping breeding records and controlled mating to help ensure that inbreeding is minimized. Managing broodstock requires the use of proper-sized fish. Consideration must be given to the fact that larger fish produce fewer eggs for the amount of food that they consume. They are also harder to handle, especially when attempting to remove eggs from their mouths. A balanced diet is needed for proper growth and healthy fish. Broodstock should be fed a high-quality feed at approximately 2% of their body weight each day. The size of your tanks and cages will determine the number of broodstock that you can manage. Stocking density should be between 1/2 to 1 fish per square foot of the water's surface area. For optimal egg production, the stocking ratios are between 2 to 5 females per male. Mixed-sex fry are the easiest for a hatchery to produce. One primary challenge with mixed-sex production is cannibalism. This can be easily avoided by keeping the fry in batches of the same size. During grow-out, mixed-sex populations can also present problems with reproduction and stunting in the culture. Mixed-sex fry are well suited for cage culture, intensive systems, and short-duration pond culture. High-density systems limit reproduction by breaking reproductive behaviors through crowding. Partial harvesting of high-density systems can lower the density and allow reproduction. The production of all-male fry offers some distinct advantages over mixed-sex cultures, since males grow at a faster rate. The use of all-male fry also limits reproduction, which permits longer culture periods in the ponds. The longer period allows for the production of larger fish. There are 4 general methods for producing all-male fry. Once the fry reach a certain size, they can be hand-sexed. At this stage, they can be identified by differences in their external reproductive organs. This process is very labor-intensive and requires that all of the females that you have raised to this point must be discarded. Sex reversal involves the use of special hormones such as methyltestosterone. This hormone is mixed with the feed during their early growth stage. It causes a sex reversal so that all females gradually become males. Interspecies hybrids are the result of crossing 2 separate species. This breeding technique uses the males of one pure strain and breed with the female of a different species. The results of mixing 2 pure lines is a male interspecies hybrid. YY male technology is a patented process involving genetic manipulation to produce YY supermales. This process is rather labor-intensive and involves progeny testing of adult males. While none of these methods are 100% effective, they represent the current methods for producing all-male fry. On the average, most results produce a 95% male population. The use of sex reversal hormones is the most common technique that is currently being used around the world to produce male fry. The specific hormone is referred to as 17-alpha-methyltestosterone. The treatment dose is 9 milligrams of hormone per kilogram of fish per day for 28 days starting at first feeding. It should be started as soon as possible, as this increases the odds of a higher percentage of males. The feed itself contains 60 milligrams of methyltestosterone per kilogram. In the U.S., possession and use of MT, or methyltestosterone, requires participation in the Investigational New Animal Drug, or INAD, project supervised by the U.S. Fish and Wildlife Service. This has resulted in a significant regulatory burden for those using this hormone, including record-keeping, testing, and training of employees. Health requirements stipulate that you cannot market sex-reversed fish under the weight of 350 grams. Since the hormone treatment takes 28 days, this means that you will have larger size fry, which adds to the shipping cost. A hatchery may want to add a nursery stage to provide larger fry to its customers instead of selling newly hatched fry. The advantages of a nursery include high stocking densities, better space utilization of your tanks, more frequent feedings and higher growth rates, shorter grow-out period for the customer. The older fry are better able to handle the stress of transport to their final grow-out site. As we mentioned earlier, the feeding rates will depend upon the size and age of the tilapia and the amount of natural food that is available to them. Some systems simply fertilize the tilapia pond and allow the fish to feed themselves. The trouble with this method is that the fish will grow slower, and it can also cause issues with reproduction in the pond. In systems where the feeding is done predominantly with artificial feeds, the feeding rates vary with the age and size of the tilapia. Newly hatched are fed 20% of body weight per day. At the age of 30 days, this is reduced to 15% of body weight. Then at 60 days, it drops to 10%, and at 90 days, it is reduced to 7%. Once the fish reach a body weight of 50 grams, the feed is 4%. This continues until they are over 250 grams, where the feed rate is 1 to 1.5% of their body weight per day. Water quality management is an important aspect of the hatchery and needed to assure a productive and healthy hatchery. Nile tilapia are the least tolerant of salinity of the commercial tilapia species. It grows well and can reproduce in salinities up to 15 parts per thousand. However, fry are much less tolerant of salinity. It is recommended that the salinity for a hatchery site be less than 5 parts per thousand. Tilapia are not cold tolerant. Reproduction stops at water temperatures below 68 degrees Fahrenheit, and disease-induced mortalities begin to appear at temperatures under 65 degrees. Tilapia are extremely tolerant of low levels of dissolved oxygen, or DO. They can survive early morning dissolved oxygen levels of 0.3 milligrams per liter, but this does not mean that they thrive in low DO water. Morning DO levels should be kept above 1 to 2 milligrams per liter. Prolonged exposure to unionized ammonia levels greater than 1 milligram per liter can cause chronic losses. Nitrite levels should be kept below 27 milligrams per liter and measured as nitrite. It is important to maintain a healthy environment for your fish in order to prevent diseases and other ailments that can kill off your fish. Disease prevention in the hatchery includes managing the quality of incoming water, quarantining new stocks to ensure no diseases will be spread when breeding new lines, supervision of visitors, especially those who may have visited other farms or hatcheries, managing the cleanliness of equipment to prevent cross-contamination from different tanks or batches of fish, disinfecting the surface area of the eggs to help prevent the spreading of disease from parents to offspring. Some of the equipment that a hatchery will want to consider before starting up includes obtaining the necessary filters and plumbing for processing incoming water. Determine whether you will be using spawning tanks, hoppas, or green water ponds. Determine whether to use egg hatching jars or allow the females to spawn on their own. Determine whether to use fry rearing or nursery tanks. How many broodstock tanks will you need? You will need to consider aeration requirements, pumps, and a source for electrical backup power. You will also need to ensure that your effluent discharge meets federal and local environmental regulations. This will often require the use of biological filtration. For more information, contact your local cooperative extension agent. All of these requirements should be considered before attempting to design and build a hatchery operation. As tilapia farming continues to grow, so will the need for hatcheries to readily supply the seed stock. A well-planned and well-managed tilapia hatchery can be a profitable and rewarding business venture. For the Pacific Islands, these seed stocks can help foster growth of local fish farms and provide consumers with a nutritious and tasty food source.